right. So once you get this cut out so that there are little flaps, not exactly like that. You weren't supposed to cut along here between, but it doesn't matter, okay? I know it's really complicated. I'm sorry that I didn't hold your hand with this. Dixie, D-I-X-I, and then Royd, R-O-Y-D. So we are in F2. We're talking about domain and range. So that's our lecture today is domain and range. Okay? So everybody to the Dixie Royd part. Everybody wrote D-I-X-I.
And then Royd?
And then Royd, R-O-Y-D. Says R-O-Y-D. Huh? Dixie Royd. Yeah. Dixie Royd. Okay, let's go through Dixie. Shh. Guys, let's go through Dixie. What do you think D stands for?
Domain.
Because he's goofing around. Domain. Domain. D stands for domain. So the domain is what? What is the domain?
I don't know.
It's like the inputs.
It's the inputs. Okay? The domain are the inputs. It's what you're allowed to put into the function. All right? Am I allowed to take the square root of a negative number? No, so negative numbers aren't in the domain of the square root function. Okay? So domain are the inputs. Inputs are also known as x values. And x values are also known as, anybody know?
Integers?
Oh, good guess, but no. They can be real numbers, but independent variables. The domain is the inputs, or the x values, or the independent variables. Okay, so domain is inputs, the x values, or independent variables. That's what the domain is. All right? So what do you think ROYD stands for?
Range.
Range. Range is the outputs. It's also the y values and the dependent variables. Okay. So range is the output, the y values, or the dependent variables. Right? So when I put an x value in, how many y values should I get out?
1.
Only one. Each x value has only one y value. The set of all x values I could put in, that's called the domain. Can you guys see it okay?
What's the last one?
Dependent variables. Dependent variables.
Can you give an example of dependent and independent? Like how they interact?
So, okay, yeah. So an independent variable means that it's independent of anything. You can choose whatever number you want. The dependent variable depends on your choice of the independent variable.
Oh, so just like if we have these numbers for x and then y are the dependent.
Yes, exactly.
Okay.
So you can choose whatever you want to put into the function, but what comes out of the function depends on what you input.
Okay.
Gentlemen? Okay, so the domain is anything that we're allowed to put into the function, and all values that f of x outputs, that's the range here. So domain is anything allowed in, and range is everything you get out. It's the set of all numbers allowed in and the set of all numbers allowed out, or you get out. Now, domain and range are infinite, right? It means we can't sit here and write down everything that we could input, nor could we sit down and write out everything that we could output. So what we do is we show that visually with a graph, or we write it in set or interval notation. And we're going to get into how to do that in a second. So I'm going to give you guys another handout for examples.
Hi, Mom.
We are recording again now. We want a color for the domain. I know it's hard to see on here. Mine's yellow. And a color for the range. Mine's going to be blue. So you can use highlighters, you can use colored pencils, whatever. It doesn't matter. Okay? Domain and range. So we talked about domain being the inputs, the x values. So now we're going to talk about how to look at a graph and figure out what the domain and what the range are or will be. Keep your highlighters and colored pencils. You're going to need them. Okay. So let's open up the booklet to the very first page. Okay? So here, domain. So what we're going to do is we're going to take our domain color. For me, I think that was yellow. My domain was yellow. My range for me is blue. All right. I'm going to make a line that creates a box around this graph that will completely and totally encase this. So for the x values for the domain, it ends right here, correct? Okay? So that's the furthest spot it is in the x direction. And what's the furthest it's going to go when I go off to the right? 7.
Oh,
4.
I'm looking
Yeah.
at the wrong one.
Okay.
4.
A 4 right here. Okay. All right, so that's the boundary in the x direction. Now let's go in the y direction. So change colors. The smallest one is right down here, correct? That's the smallest y value. And the biggest y value right here. Now I've created a box, yes?
Yes.
Completely encases my function, my graph. So now it will be easier to see what the domain and what the range are. So what is the domain? So in set notation, remember set notation is the one with the curly brackets. The set of all x such that x is what?
Negative 2 and
4.
2.
All right, what's the relationship between negative 2, x, and 4?
Less than
Less than
x. Less
or equal to?
Less than
Okay. So x is greater than or equal to negative 2, but less than or equal to 4. Does that make sense? Negative 2 to 4. All right? Negative 2 to 4. In interval notation, how would I write that?
y.
You would do a bracket. So it's
A bracket?
A bracket with -2 and then comma 4 bracket.
Excellent. Why would I use brackets? Yeah.
Brackets is used to describe that it's on the point or equal.
Yeah, exactly.
It doesn't go past this point.
Right, it doesn't go past this point, but it can be negative 2 and it can be positive 4, right? And anything in between. What about the y values? So the range is the y such that
Negative 3 is less than or equal to y.
4 and negative.
Which is less than or equal to 4.
Okay, does that make sense to everyone?
So why negative?
Negative 3 because we're doing the blue values, right? Negative 3 is the smallest.
We can take whatever.
No, we need to pick, here's the smallest value. Here there's a dot, right?
And why is the y in the middle? I forgot. Why is the y in the middle? I forgot.
Well, because this says y is bigger than a negative 3, but
Oh,
less than 4.
Yeah. Okay. Thanks.
Yeah. So in interval notation, I'm going to write negative 3, comma, negative 4, just like above. Does that make sense to everyone?
Why is it negative 4?
Because
No.
that's the highest place that the thing is.
That's a good point. I was just seeing how many people were actually listening to me.
I completely trust your judgment.
Don't completely trust my judgment. It's bad judgment sometimes. Actually, I don't know why I wrote negative 4. All right, do the same for this one. Write your domain boundary, which is right about here.
I'm sorry.
Then your range. All right. Do you guys have that box? Yeah? So what's the domain? It's the set of all x such that,
-1 is something equal to x, which is less than equal to 7.
yeah, it's actually a,
That's -1.
it's a
Oh.
-2 because of the -1. Yeah, okay, that's okay.
Sorry.
-2 is less than or equal to x, which is less than or equal to what? 7, yeah. So you're right, Lily. Don't apologize. Yeah. And then in that's set notation. In interval notation, what's the answer?
To bracket -2.
All right, y for the range? I think that's a -3. Less than or equal to y. Less than or equal to what? 6. 1, 2, 3, 4, 5, 6. Yeah. So -3, comma 6. Good. Does that make sense to everyone? All right, so let's get a little bit more complicated. Yeah. Why is the y less than or equal to what? Got it? Okay. All right, so for this one, what do you notice about, so my domain, it ends here, but what do you notice about the top of this line? It's a circle, so I'm going to draw a dotted line here. Why dotted line?
Because it's not included in the range. Sorry.
Domain value? Correct. So it's not included. It goes right up until that point, but doesn't include that point. So the dotted line just says, go right up until here, but there's a fence here. You can't go beyond this, and you can't be this value. And then the same kind of happens for my range too, right? My range, I draw a solid line for the -3, but what happens at the +3?
It's dotted line.
It's also a dotted line because that circle is open.
I don't understand. Like, why is it closed and why is it open?
Why is it closed and why is it?
Like why is it dotted line and solid line?
So because this point is open, right? So my boundary is 3, but it doesn't include 3. Does that make sense?
Yeah.
Yes? When it open, it means not this value, but anything really close to this value. So it's like a hole, right? You could go right up until the edge of, what is that? That is 3, right? You can go right up to the edge, but you can't actually equal that value. Okay? And if we're looking at the domain, you could go right up until 4. So you could be 3.99, 3.9999, 3.99999999, but you can't be 4. You can't plot 4. It doesn't have an output. Yes?
I have a question. For these points, does it only go up to the points?
Yes, because there are dots, there are no arrows. It's just this line segment.
Okay, so they would be just be infinity.
We're going to talk about that next.
Okay.
All right. So for this domain, it's the set of all x such that is less than or equal to x. That's it. Oh, sorry. Whoa, it's no. There's a line here which is less than 4. Yeah, thank you.
Oh, it's not equal to.
Right, it's just less than 4.
Oh yeah.
Right. So in interval notation,
-2, 4, with a round.
yeah, the parentheses.